Imagine this. While you're sipping coffee in your Boston apartment, you describe a self-cleaning water bottle that tracks hydration to your smart speaker. And by noon, a drone delivers it, custom molded to your grip, with a screen glowing your electrolyte levels. This isn't magic, it's the imminent reality where AI, 3D printing, and smart materials all come together to turn imagination into physical objects overnight. So let's explore how this trillion-dollar revolution is going to reshape, well, pretty much every aspect of our lives. The engine of this transformation has three pistons firing in unison. First, AGI acts like a universal translator between human whims and machine instructions. When a London designer says, "Create earrings that look like frozen starlight," systems like DeepMind's AlphaFold for materials don't just sketch designs. They calculate quantum-level molecular bonds, simulate light refraction in crystalline structures, and prototype 20 material combinations in digital space before printing. MIT recently used this approach to invent a 4D printed violin string that tightens itself using humidity changes, delivering perfect pitch in any climate. Second, 3D printing has evolved from just making plastic trinkets to becoming an industrial alchemist. In Texas, Relativity Space's Stargate printers now fabricate entire rocket engines in 30 days, each nozzle containing 100,000 fewer parts than traditional models. Meanwhile, HP's multi-jet fusion printers in Barcelona hospitals are producing titanium spinal implants with lattice structures precise enough to mimic human bone porosity. The secret? Voxel-level control, basically manipulating materials at the equivalent of digital pixels, so a single printer can output objects combining rubber, metal, and biodegradable plastics in seamless gradients. Third, material science breakthroughs are honestly rewriting the physics textbooks. Dutch scientists have engineered living concrete infused with bacteria that heal cracks and absorb pollutants, a material now coating Rotterdam's bicycle paths. In California, a startup called Foray Bioscience grows lab-printed wood with growth rings controlled by AI, creating furniture that's lighter than aluminum, yet stronger than oak. And the most radical one? A 4D printed hydrogel from Harvard that assembles itself into functional micro-robots when exposed to body heat. It's set to revolutionize targeted drug delivery. This convergence is already transforming industries. In Munich, BMW's instant customization program lets drivers verbally redesign car interiors, say something like racing seats with Swedish massage, and local microfactories print personalized components within hours. The fashion world's seeing similar upheaval. New Balance's Boston lab prints 3D woven shoes that adapt to runners' foot swelling mid-marathon, while Stella McCartney's bio-fabricated dresses grow floral patterns that match the wearer's microbiome. Even architecture is evolving. Zaha Hadid architects used AI to design Dubai buildings with 3D printed facades that shift shape to optimize sunlight, reducing cooling costs by 40%. The medical revolution is perhaps most profound. At Philadelphia's Wistar Institute, bioprinters now create cancer-fighting lymph nodes using patients' own cells. Swiss researchers, they've 3D printed corneas that actually outperform human transplants in trials. Meanwhile, a French firm called Biomodex produces hyper-realistic organ replicas, so surgeons can practice complex operations before stepping into the real thing. The next frontier? Well, nanoscale printers being tested at ETH Zurich that can reconstruct damaged neurons, potentially reversing spinal cord injuries. That's just incredible. Yet this power demands new ethical frameworks. The EU's recent Digital Genesis Act now requires all AI-generated designs to embed blockchain watermarks, aiming to prevent IP theft. Over in California, there's legislation that bans 3D printing of firearms unless they include biometric locks, a direct response to blueprints spreading on dark web forums. And luxury brands? They're facing some pretty existential questions. I mean, when someone in Paris can print perfect replicas of Louis Vuitton bags right at home, what even defines value anymore? LVMH's answer? They're developing this digital scent technology where each printed item emits a unique fragrance that's verified by blockchain. The environmental impact could be honestly transformative. McKinsey estimates that distributed manufacturing might eliminate 1.5 billion tons of annual transport emissions. That's like grounding all planes globally. Adidas's Future-Craft loop shoes, which are fully recyclable through 3D printing, have already kept 11 tons of waste out of landfills. But yeah, it's not all smooth sailing. MIT studies warn that if safety protocols fall behind, uncontrolled nanomaterial production could lead to what they're calling digital asbestos. We stand at civilization's inflection point. NASA's Artemis program is set to deploy lunar 3D printers that use moon dust to build habitats, proving this isn't just about consumer goods, but really about humanity's expansion into the cosmos. Back here on Earth, the implications are, well, staggering. We're shifting from globalized to localized, production moving from massive Chinese factories to neighborhood print hubs, from mass production to mass imagination, where every person becomes both designer and manufacturer. And from planned obsolescence to eternal upgrade. Your phone case, for example, could evolve with you, its material renewing every year. But the final barrier? It's not technological, it's psychological. When a child's doodle becomes a functional drone, or grandma's knitting patterns turn into AI-generated couture, we've got to relearn what it really means to create. This isn't just a new industrial revolution. It's the dawn of human creativity's second genesis, where every spoken word holds the power to shape reality.